Suppose we're given the series n equals 1 to infinity of 1 over n squared plus 8. How would we be able to use a comparison test to be able to deal with this problem? Well, for me, limit comparison test is again going to be the easiest and the quickest because we have nothing on top here and we have n squared as the highest term there. So we should probably compare it to the series from n equals 1 to infinity of 1 over n squared, which we know converges. Now let's just do the part of the limit comparison test. We take the limit as n goes to infinity of 1 over n squared plus 8 times the reciprocal, so n squared over 1, which is just going to be the limit as n goes to infinity of n squared over n squared plus 8. Again, you could use L'Hopital's rule twice because you have infinity over infinity, or you just divide everything by n squared, and you will have 1 over 1 plus 8 over n squared. This part goes to 0, and you get 1. And once again, 1 is between infinity and 0, and it isn't 0 or infinity. So the convergence of this series is assured by the limit comparison test. Now suppose we are uncertain and we, for some reason, used the limit comparison test with 1 over n. Well, what would happen? Well, we would know that this one diverges. And when we take our limit, we would still have our 1 over n squared plus 8 times n over 1, which is just going to be the limit as n goes to infinity of n over n squared plus 8, which when we divide things by n, we get the limit as n goes to infinity of 1 over n plus 8 over n, which will just be 0. But 0, C, is not fitting this condition. It's actually equal to 0. So we can't use the limit comparison test. So we'd have to pick a different series to use the limit comparison test with.